All right, so this is 3.2 part 2. It's the second half of the log function. So we focused on the first half for the quiz, which was graphing. But today we're going to look at properties of our log functions. So we mentioned it before, but we can have a log function and put it in exponential form. And we can also have an exponential function and put it in log form. This comes in handy because we can't calculate logs like in our head. It's a button in the calculator that we can use. But if we don't have a calculator, it may be helpful to put it in exponential form. That way we can calculate it. So when we have a log function, we read it as log base A of x. So this would be log base A of x. So the little number on the bottom is the base. I don't think it mentions it in the notes, but if we had log base 10, so if we had log with base 10, that would be our common log.
I couldn't find an apron.
And then if I had log base e, that's our natural log. And log base e, we can also write as ln. So I think it mentions it in the notes somewhere. But just in case, it'll ask you a couple questions like these on WebAssign. All right, so log form versus exponential form. So log form will always have the word log in it, and exponential form is always going to have an exponent. So I'm going to write an example down at the bottom. Let's say I had log base, my pencil stopped working. Let's say I had log base 2 of x is equal to y. I always start with the base, which would be what? 2. So I always start with the base. That's going to be my big number. And then the other two numbers switch positions. So it would be 2 to the power of y is equal to x. So you always start with the base. That's going to be your big number. And then the other two just flip. So notice here that it looks like kind of 2 to the power of x. It's never going to be the same thing when you put it in exponential form. That x isn't going to be connected to the 2 anymore. It's going to be the y. So for example 1, we have to write each equation in the equivalent exponential form. So for a, what's my base? 2. So I start with 2. What's going to be my exponent on 2? 4, and what's it equal to? X. Awesome. Right now I just want to put it in exponential form so we don't have to solve it yet, but there will be questions that we're going to solve. All right, for the second one, what's my base? 3. What's going to be the exponent on 3? X, and what's it equal to? 9. So notice how it's 3 and 9. Those are not going to be the ones that are touching. So you always just switch the position of the other two. Any questions here? All right, now we're going to put it in log form. So log form, we always need the word log. So what's our base going to be? B, perfect. It's always going to be the base that has the exponent. What do you think will come next? 16, and what's it equal to? 4. So then for B, we always start with the word log. What's my base? 5. What comes next? X, and what's it equal to? 2. Awesome. For A and B, we need our calculator. So it says evaluate the function at the indicated value of x. Oh, without using a calculator. I'm just kidding. I think there's a couple in here that we use a calculator. But for this one, we can do it without. So I'm going to plug in 64 into x. So I have log base 4 of 64, and it's equal to some number that we're going to try to find out. So we can't evaluate log without a calculator, but I can put this into exponential form to figure out what this is equal to. So what's my base? 4. What's going to be the exponent? X. We can call it x. What's it equal to? 64. So 4 to what power gives me 64? 4 to the third power is 64. So that means x is 3. Here it uses x, so we can't really say x is 3, but the answer here is 3. For the next one, I'm going to plug in 1/6. So when I put this into exponential form, what's my base? 36. What's my exponent? X. And then it's equal to 1/6. So 36 to what power would give me 1/6? So we know it's going to be negative, right? So making it negative would make it 1 over 36. But it's going to be smaller. So what type of exponent makes my number smaller? Awesome. 1/2. So what's x equal to? Negative 1/2. So remember, a negative exponent makes it a fraction, but a fraction as an exponent makes your number smaller. So this page just talks about entering it into the calculator. Some calculators are different. So notice here, if we're taking the log of 1,000, some calculators you type 1,000 and then log. Some calculators you have to do log 1,000 and then enter. So every calculator is different. You just have to know how to use your own calculator. And then also, not many calculators will let you change the base. So if you typed log into your calculator, it doesn't give you a base. It just says log, and then you put the next number. Every calculator just assumes that it's a common log, so it's log base 10. So the calculator just automatically assumes that it's log base 10. Some of the newer calculators you can change the base, but some you can't. So this is log base 10 of 2.7. So we would click in our calculator log of 2.7, or some calculators you have to do 2.7, then hit log. So what do we get when we find the log of 2.7? 0.431. Do we agree? And then last step, we would multiply it by -3. So this times -3. And what do we get? -1.29. Perfect. All right, on the next page, we have some more properties of logs. So if I had the log of whatever base of 1, that is equal to 0. Because if I put this in exponential form, my base would be a, my exponent is 0, and it's equal to 1. What is any number raised to the power of 0? 1. So if I take the log of any number, that's always going to be 0. So if I take the log with whatever base, the log of 1, it's going to be 0. If I have the log base a of a, that is equal to 1. Because our log base a of a cancels, and whatever our exponent is here, so here our exponent was just 1 because it's just a, that would be our answer. So another example we might see is if I had log base, let's say 10 of 10 squared. What do you think our answer would be here? 2. Because the log base 10 of 10 cancels. We're just left with whatever the exponent is. So that kind of ties down into number 3 too. If I had log base a of a, log base a of a cancels, and our answer is whatever the exponent is. And the same thing works if I am in exponential form. If my base is a and I had log base a, they cancel, and I'm just left with whatever I'm taking the log of. And then if I had a log is equal to a log and they had the same base, I just set the remaining parts equal to each other. So I can take log base A and cross them out and then just put the rest of it equal. So if I had log base 2 of 4 is equal to log base 2 of x. Log base 2 and log base 2 cancel. So what's x equal to? 4. So I would just set the remaining parts equal. All right, so we are solving the equation for x. So I could put this into exponential form, or I can apply one of my properties. Can I make 81 have a base of 3? It would be 3 to what power? 3 to the 4th power. So now that I have log base 3 of 3, they cancel, so what's x equal to? 4. Another way of doing this would just be to put it in exponential form. So this would be 3 to the power of x is equal to 81. And 3 to what power is 81? 3 to the 4th power, so x is 4. So you could do it either way. You could apply your properties and get it to cancel if it's the same, or just put it in exponential form. So for b, I have log base 5 of 1. What would that be? Awesome, 0. Anytime I take the log of 1, doesn't matter what our base is, we get 0. So x is 0. Again, we could put this in exponential form to see it a little bit better. If I had 5 to the power of x is equal to 1, 5 to what power would give me 1? 0. So these are kind of just two different ways of solving it. All right, this next page. Use the properties of logs to find the answers. So for a, what do you think my answer would be? 15, awesome. Because 3 to the power of log base 3 cancels, and I'm left with 15. For b, what do you think? 3. Log base 2 of 2 cancels, and I am left with 3. For c, awesome. 1. Log base 9 of 9 would cancel, but 9 has the exponent of 1, so my answer is 1. And then for d, what do we think? How can I make 1/3 have the base of 3? Awesome. It would be 3 to the power of negative 1. You can change 1/3 and make it 3 to the power of negative 1. So log base 3 of 3 cancels, and I'm left with negative 1.